the radius is going to change, right? This is very similar to what we do here. Notice, let's say positive x is me walking this way, right? From your point of view, this is positive x, right? Now, basically what this function is saying is that when x is equal to 0, I'm going to start at 1. So let's just say right here this represents a y value of 1. When I start walking to the right, what happens to the y value? It increases. So basically it increases at a slope of 2 and gives me a straight line. Okay, as a matter of fact, it's going to look like this picture right here. Now, think about the same thing for a polar equation. Okay? Now, for a polar equation, instead of saying that x is getting bigger, in other words, going in a straight line, what's going to happen is theta is getting bigger. So think of it this way. Let's say theta right now is 0. And let's say I'm turning. I notice I'm turning counterclockwise, right? That's how you get a bigger r. There should be a bigger theta. So what's going to happen is, as I'm turning, the r is going to start to get bigger. Then it's going to get really big. And then it's going to start getting smaller. Then the r is going to be negative. And then it's going to go back to 0, and then positive again, and so on. Does that make sense? Okay, well, let's draw it. So, when we have an angle of 0, what's r? 0. So that's just the point in the middle, right? The center. That's easy. Now, when the angle is 30 degrees, we know that r is 2. So if I turn by 30 degrees, I'm going to go the second ring. Now, by the time we get to 60 degrees, we're at 3.46. Actually, I'm going to need one more ring. 3.46 is about right there. Everybody agree? So again, if I turn to 60 degrees, notice it's about halfway between the third and fourth ring. Now, by the time I get to 90 degrees, which ring am I going to use? 4. Now, when I get to 120 degrees, I'm going to have the same r as I did here, right? 3.46. And then by the time I get to 120 degrees, what are we going to get? Oh, I'm sorry, that was 120 degrees. By the time we get to 150 degrees, what do we get? Right, we get 2, which notice is horizontal to this, right? Now, so far, it looks like we just kind of went in a circle. Now, you guys know that my art's not the best, okay? But it turns out, if I were to actually draw this very carefully, okay, this should actually look like a real circle, okay? And when we do it on the calculator, of course, the calculator can draw a lot better than I can. All right, now, let's keep going and see what happens. Now, if we get to an angle of 210 degrees, now watch this. This is 180. 210 is this way. What's r? Negative what? Negative 2, which means you go backwards to this point, right? And then guess what? The next angle, which is here, you're going to go backwards to this point. The next angle, which is here, you're going to go backwards to this point. The next angle, which is here, you're going to go backwards to this point. The next angle, which is here, you're going to go backwards to this point. And then you're just going to keep going around that circle. And that's the graph. So the whole point is that equation, r equals 4 sine theta, gives us the equation of a circle, right? As a matter of fact, you guys learned how to write equations of circles before. Remember this? So before today, if I were to draw this picture, okay? And by the way, let me draw it on a rectangular coordinate system. Okay, so if I were to draw this picture, I draw terrible circles. But anyway, if I were to draw this picture and ask you to give me the equation of that circle, well, obviously before today you didn't know how to write it in polar form. You would have to write it in rectangular form. Does everybody remember how to do that? Remember we have remember that? That's the equation of a circle, right? What is the radius of that circle? Well, look at it. What's the radius of that circle? 2. What's 2 squared? 4. Okay, well, that's easy. Now, x minus h. Well, h would be the x coordinate of the center. K would be the y coordinate of the center, right? So, x minus what?
0.
Right, so, and then, what do I write next? And of course, I can just write that as x squared, right? So therefore, we have that. That tells me that this rectangular equation is equivalent to this polar equation. Okay? They're exactly the same. My question for you right now is to prove it. So this would be a good time for